All right, so in this video we're going to do a couple problems here. So in this case I've only given g of x. I haven't given any f of x at all. And the question is, if we're given some point on f of x, then what can we say about g of x? In particular, what point must be on g of x given that this point is on f of x? Likewise, if we're given a point on g of x, what point must be then on f of x? So a way of understanding this question is essentially saying, okay, if you have the point 1, 1 on f of x, where does it go under this transform? Because g of x is just a bunch of transformations applied to f of x, right? So if we know 1, 1 is on f, where does it go to get, when it goes through all these transforms, where does it end up when we're talking about g of x? Now we can do this geometrically and we can do this analytically. So the first thing I'm going to show you how to do is to do this analytically. So to do that, remember that when we say the point 1, 1 is on f of x, what this is saying is this is an x value and a y value. So what this is saying is that f of 1 equals 1, okay? So given that I don't know anything about f, the only thing I can evaluate then, the only thing I know on f for sure is f of 1, and I know that that is 1. So that means that I need to sort of pick an x value here that will rig it in such a way that when I actually plug in the x value, all of this will collapse down to 1 so that I can do f of 1 here and actually replace it with what I know it is, because it's the only point I have, right? So what that's saying is I need the whole inside 2x plus 1, the whole inside, to equal the one thing I could evaluate, 1. But now I have an equation where I can solve for x. So I can take, for example, minus 1 to both sides. So 2x is 0, divide both sides by 2. I get x is 0. So this says that if I plug in 0 for x here, this will become f of 1, and I can replace that with 1. So once I know the x value, now I need to get the y value, and I literally do that by doing what I just said, plug in that x value, okay? So I'm going to evaluate g at 0. So g of 0, which is the y value on that point. And I'm going to write what g is, but I'm going to replace the x with the x I've chosen, 0. So it's going to be negative f of 2 times 0 plus 1. Oops. Did it again. There we go. So 2 times 0 plus 1 minus 1. Close. Okay? So in order to figure out what y is, I have to calculate this. Now the good news is, the reason I did this up here, right, is that I'm going to now be able to write this as 2 times 0 is 0 plus 1. And now I have f of 1, but I know what f of 1 is, right? f of 1 is 1. So I can replace all of f of 1 by what it is, 1. So this is negative 1 minus 1, which is negative 0, which is just 0. So if I plug in an x value of 0, I get a y value of 0. So the point on g of x is 0, 0, where, to be clear, this first 0 is what I plugged in, which is what I solved for over there, right? And the second 0 is what I got as a solution. Okay? So let me maybe do the other one over here. Now the good news is, so to reiterate, this was giving a point on f, and I needed a point on g. If it's the other way around, though, I'm given a point on g, and I need a point on f, it turns out that one's actually a lot easier. Because, again, we're going to do the same thing we did here. This is a point on g, which means that I have g of 4, right, the x value, equals negative 2. And what I want is to be able to write it something like this. So what I want, which I'll write over here, is I want f of something equals something. That's the goal. But I already have g in terms of f over here, right? So I'm literally just going to take the 4, plug it in where there's an x, and rewrite this side, right? So just so I have enough room to write, I'm going to say minus 2. This is the g of 4. But that is negative f of 2 times 4, right? I'm replacing the x's with 4, plus 1, all minus 1, close bracket. Okay? And now what I need to do is isolate. So I'm gonna put all this stuff together and isolate the f term. So the outside stuff I'm gonna move over, right? The most outside thing is -1, so I'm gonna multiply both sides by -1 to get rid of it. So minus 2 times minus 1, that's 2. That gets rid of that minus, leaving me with f of 2 times 4 is 8, plus 1, minus 1. So then I'm going to have plus 1 to get rid of this plus this minus 1. So I'm going to have 3 equals f of 8 plus 1 is 9. But now I have f of something, 9, equals something, 3. So just like over here, right, 1 and 1, this is the x value, this is the y value. So the point that I get is 9, comma 3. Right, the 9 thing inside f, the 3 the thing it's equal to. The important thing here is I have f of stuff equals something. I don't have f of stuff with more stuff. I don't have something times f of stuff, right? I just have f of single number equals single number. That's it. Okay? So here I had 0, 0 going that direction. Here I have 9, comma 3. All right. And that is it.